Hello everyone. So this is a question from JEE Advanced 2025 paper 2. The correct sequence or reaction sequence that would produce a dicarboxylic acid as the major product is, okay. So here we need to underline these points, that is dicarboxylic acid and also major product, okay. So basically we want those reaction sequence which ultimately that will give us a dicarboxylic acid, and such sequences are given to us. The chapters involved is haloalkanes and haloarenes, aldehyde ketones and carboxylic acid, biomolecules and alcohols. Okay. So before we proceed, we need to understand the meaning of this term, that is dicarboxylic acids. So carboxylic acids, they are classified as mono, di, tri and poly carboxylic acids according to as they contain 1, 2, 3 or many carboxyl groups in their molecules. Okay. So they can be known as di, tri, mono or poly depending upon the carboxyl groups that they contain in their molecules. So in the case of a dicarboxylic acid, we will have two carboxyl groups. So we will have two COOH groups, two of them. Okay. So we have to look out for those carboxylic acids which have two COOH groups in the molecule. Okay. So if we look at the sequence A, so in A, the starting molecule is OH, CH2, CH2, Cl. Okay, and the first reagent that we are using is NaCN, right? So due to this reagent attacking on this substrate, we'll be getting the answer will be OH, CH2, CH2 and Cn. Okay, so you might be thinking, or you might be having a question, why this Cn minus, that is nucleophile, did a nucleophilic substitution with this Cl minus and not with this Cn minus, not with this OH minus, right? So that is because Cl minus is a better leaving group. So this Cl minus is a better leaving group than OH minus. That's why, nucleophilic substitution happened between this Cn minus and this Cl minus. That's why we got this product. Okay, cool. Then after we got this product, so we react it with OH minus and H2O. So that is basic hydrolysis in the presence of a base. Okay, and this is a nitrile group. Can you see? So nitriles, they undergo hydrolysis to amide. Whenever we do basic hydrolysis, nitriles will change into amide. So therefore we'll be getting OH, CH2, CH2, C double bond O, and H2. Okay, and the third reagent that we used was H3O plus, which is basically acidic hydrolysis. That is, H plus and H2O, acidic hydrolysis. So we have an amide and we are doing acidic hydrolysis to it. So we'll be getting a carboxylic acid. So if we continue to hydrolyze amides in the presence of acids as catalyst, we get carboxylic acid. Okay, so I will write down this important point. If we hydrolyze amides in presence of acids as catalyst, we get carboxylic acid. Okay, so we'll be getting, our final answer will be OH, obviously CH2, CH2, C double bond O, OH. Okay, so this is not the correct answer, obviously, because this is a monocarboxylic acid. You can see there is one COOH group. Okay, so therefore A is not the answer. Okay, so let's go and have a look at B. In B, the starting compound is nothing but the open chain structure of glucose. That is, B is nothing but CHO, CHOH, third carbon it will be reversed, fourth and fifth again HOH, and on the 6th carbon we'll have a primary alcohol group, right? So this is the open chain structure of glucose, and glucose on oxidation with a mild oxidizing agent like bromine water. Okay, so you can see in B the reagent that we are having is Br2 water, that is, it is bromine water. It's a mild oxidizing agent, so it will give us gluconic acid. Okay, so gluconic acid is nothing but this CHO is replaced by a COOH group and everything else remains same. Okay, so we can represent this in this fashion, that is CHO, CHOH, 4, CH2OH plus the nascent oxygen which has been provided by the oxidizing agent Br2H2O, and ultimately we'll be getting gluconic acid, which is COOH, CHOH, 4 and CH2OH, right? So we can clearly see B is also not the correct option, right? Because again it is a monocarboxylic acid, it has only one COOH group. Okay, cool. Let us look at C, option C. Option C, we have bromocyclohexane. So we have a bromine atom and attached to a cyclohexane. Then the first reagent is KOH in the presence of ethyl alcohol. So obviously elimination is going to happen. Okay, so in C the starting compound is a haloalkane, and whenever a haloalkane is heated with a concentrated alcoholic solution of potassium hydroxide, elimination happens and we get an alkene. Okay, so I will write down this statement, important. When haloalkene heated with a concentrated alcoholic solution of potassium hydroxide KOH, so alkene is formed. How does this happen? Hydrogen eliminated from beta carbon and halogen eliminated from alpha carbon. To understand this, so let's look at our starting compound of C. So this is the alpha carbon and obviously this is the beta carbon. It has, beta hydrogens, you can see. So as we have mentioned, hydrogen is eliminated from beta carbon, so this sigma bond will form a pi electron pair, pi bond there, and this bromine will take away these electron pairs and go away. Okay, so showing this by arrows, so bromine takes these electron pairs and these pi electrons became sigma, these pi sigma electrons become pi bond, and this H also goes away in the presence of KOH, obviously. So obviously we'll be getting cyclohexene, right? Because bromine went out and these sigma electrons became pi electrons or a pi bond. Okay, so we'll be getting cyclohexene, and bromine went out with and K plus combined with bromine to give us KBr, potassium bromide, and H also went out and OH minus was left, so we will also get a molecule of water as one of the side product, so KBr plus H2O, right? Cool. And the next sequence on cyclohexene is KMnO4, H2SO4 and heat. So you can see this is an alkene and we are treating an alkene with a very strong oxidizing agent in acidic conditions, and also it is very hot, so this implies drastic conditions. So normally, depending upon the structure of an alkene, whenever it is acted upon acidic potassium permanganate, alkenes either convert to ketones or acids depending upon the nature of the alkene. Okay, so I'll write that statement. Acidic KMnO4 oxidizes alkenes to ketones and or acids depending upon nature of the alkene. Okay, so in our case, so I will draw the cyclohexene again. In our case, here the bond is going to rupture or it is going to break, and let's give them numbers 1 2 3 4 5 6, and upon rupture, carbon number 1 is going to get oxidized to acid, carbon number 6 is going to get oxidized to acid. Okay, so we'll be ultimately getting carboxylic acids because we are using very harsh conditions, and also acidic KMnO4, right? And the other carbons will remain as it is, 2 3 4 5 will remain as it is. So ultimately we will get, due to action of KMnO4 and H2SO4 and heat, will be getting, so I will write them like this: CH2, 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 give them numbers 2 3 4 5. So they are as it is, and the first carbon will become COOH, the sixth carbon will also become COOH. So this is 1 6, right? So can you see this is the correct answer, because it is a dicarboxylic acid. One molecule contains 2 COOH groups. Okay, anyway, let's look at option D also. So option D is saying that we have CH3, CH, CH3, C double bond O, CH, CH3, CH2, OH, and the reagent that we are using is H2CrO4, which is a very interesting reagent. Okay, the name of this guy is chromic acid, so this is chromic acid, and the structure of this guy is Cr double bond O, double bond O, OH and OH. Okay, so it is a strong acid, and it is also a reagent for oxidizing 1 degree alcohols and aldehydes to carboxylic acids and secondary alcohols to ketones. Okay, so I will write this down. It is a strong acid, and it is used to oxidize 1 degree alcohols and aldehydes to carboxylic acid and 2 degree alcohols to ketones. Okay, so it does not oxidize ketones under normal. It does not oxidize ketones under normal or mild conditions. So for example, you can see the starting compound consists of a ketone group. So it does not oxidize this ketone. It does not affect this ketone. It does affect this primary alcohol. It will convert this primary alcohol into a carboxylic acid. Okay, so to convert this CO group, or to oxidize this CO, we will need very strong oxidizing agents like hot concentrated KMnO4 to break these bonds. Okay, H2CrO4 or chromic acid cannot do this. Okay, so I will write down this statement. H2CrO4 does not oxidize ketones under normal mild conditions, and therefore this part of the molecule will remain as it is, and this part of the molecule become a carboxylic acid. So ultimately, after reacting it with H2CrO4, we will get CH3, CH, CH3, C double bond O, CH, CH3, COOH, right? So this is the final answer, and you can see again this is not the correct option because it is a monocarboxylic acid and it contains one COOH molecule, sorry, one COOH group in the molecule, right? And they are asking us which reaction sequence would produce a dicarboxylic acid. So the answer is going to be C, because C gives us a dicarboxylic acid. Okay, the answer is going to be C. So this will be the answer. Okay, thank you.